Our next speaker is Dr. Amir Alush. Amir Alush is the co-founder and CTO of Visual Layer, a company dedicated to improving the quality of image datasets used in AI model development. He holds a PhD in computer science, in computer vision and machine learning from Bar-Ilan University, and has extensive experience in the field, including roles at Quaris AI and Broadman 70. His work focuses on AI system design, deep learning, and computer vision. His recent project, FastDupe, opens new windows, showcases his commitment to practical data-driven solution in AI.
Yeah, hi. Can you hear me? Great. So thank you all for coming. So I have a bit of a background story just to set the scene. So I did a PhD on discrete optimization problem, mainly graph clustering. That was for implications of computer vision, mainly old school image segmentation. So I started from classical machine learning, classical computer vision. Then I started moving into deep learning back at 2012, developing a large-scale visual search engine. My previous company was called Broadman 17. I was leading there the development of a perception stack using proprietary deep learning networks running on low-power devices. So we handled huge tons of data. So this is why I'm telling you this story. My newest company called Visual Layer, funded it together with Danny Bixson. And the presentation will try to quickly go over what we're doing at Visual Layer. On a personal note, I'm married. I have 2 children. I have also a new dog. So it turns out that my kids have a birthday next week. So last night, my wife naively asked me, honey, can you please fetch me some images of the kids, but they have to be together, and the images has to look very nice. So I was a bit of a shock. I wasn't aware that that was part of the deal. I thought my part was just pushing the data inside our Dropbox account, not taking it out and searching. So I did a quick calculation. It turns out it will take me around 500 hours just going through this massive mess of digital data. We have only as a family. In my previous work, as I mentioned in automotive, it turns out that this problem of large-scale data and the data mess actually haunted me. So we had a car driving and collecting data on a continuous basis. So that was a huge amount of data just constantly piling up. And the process of getting this data into production, into data set to train our AI model was actually a business critical problem. And that process is called data curation, taking raw data and turning it into refined, curated data sets. And the data curation process is actually a multi-step process. It's made out of this step. So first you have the cleaning. You have to remove all the outliers, anomalies in the data, perhaps some wrong annotations if you have already. Then you would like to enrich them. We heard in the previous talks about auto-labeling and foundation models. Then you would like to explore. So the basic operation of exploration is, of course, visualizing the data. You would like to look at your data and also search. And then you would like to sample, get a subset of the data, and fetch it into your downstream training process. So it actually shocked me that in my private life and also at work, all of the work, including visual data, is mostly done manually, as we all know. And this is, of course, takes a long time. It costs a lot of money. And even after you spend all this time and money, you still get very low quality data. And we are actually, most of us are not aware of the bad quality of the data. So a couple of years ago, together with Danny, my partner, we had this idea coming from the pain point we had from our personal lives and also at work. So we said, let's go over some very famous academic data set. So we looked out over ImageNet, Coco, Lion, all types of huge data set with hundreds of people probably used. I guess most of the computer vision models in production are based on this data set. And we said, let's analyze this data set. Let's see what is the level of quality in this data set. And shockingly, around 30% of the data has some kinds of mislabels, duplicates, outliers, and corruption. And that was not something that was generally known. So we've actually wrote a blog post about it. We called it Large Image Dataset Today RMS, and you're welcome to read it and see the analysis there. Main problem there was duplication. A lot of the data is actually duplicated. So it seems very trivial that you would know if you have 2 images or 3 images or 5 images that are the same, but they are not. So we actually open sourced, not exactly open source, but let's call it open source, the tool we've used to curate this data set and do the analysis. We call this tool FastLoop. So it's based on a very efficient C++ engine. What the tool actually does is taking your entire data set, builds a graph on top of it. And once you have the graph, it allows for Python developers, which are data scientists or other small programmers, to use these efficient building blocks and find some, and actually call for some very interesting functions like find me duplicates, cluster the data, perform some graph search. The tool got a huge amount of popularity. We almost reached 400K installation. We estimate that around 50 billion images were processed locally. We don't have access to the data using FastLoop. It's very simple to use, only 3 lines of code to get you started there. So why is data curation important? I guess all of us know that, but there is a huge shift from back when I started doing computer vision. We had a lot of model development. These days, most of the algorithms are actually open source. Today, they are called foundation models. So basically, what most of us do are taking existing models and fine-tuning them for our own application. So we are fine-tuning the data set in order to retrain the models. So we decided that that's a very important task. So for the last year and a half, we've taken FastLoop to the next level, and we actually built a data-driven platform with the 3 main pillars inside. One is exploration, the other is enrich, and the third one is extraction. Exploration seems like very basic, but imagine you have 1,000 images or 10,000 images or 100,000 images or 1,000,000 images. What happens if you have 1 billion images? How do you look at this image? Not even standard tools to look at this vast amount of data. It's practically impossible. Either you need to write your own tools or you don't see your data. And that also explains the large amount of quality issues and problems with data. You would like to enrich them. You would like a way to automatically or in a systematically way, you think of a database to enrich your data set. And you would also want to sample the data, extract meaningful information out of it. We released recently a public VL dataset. So using our new platform, users are actually able to explore the data interactively. Here we're looking at a very famous data set. It's called COCO. So we clustered all the images together. So this is the basic unit of visualization. You can also create ad hoc clustering by doing a visual search. And also, we are able to analyze automatically qualities issue in your data. As I mentioned earlier on the analysis, now you can all go inside and actually explore the data set you are all using. So this is an example of some objects. Some are labeled as a sink, some are labeled as a toilet. So it seems funny, but we see a lot of these examples. There are hundreds, thousands, tens of thousands of quality issues inside. Let's look at another example. So this is the Food 101. A data set should be completely dedicated to food. But as we'll see soon, when we look on the outliers, we'll see that there are many images inside the data. They are not related to food at all. And shortly, you see all these anomalies. And shortly, we will get to see Batman. Did anyone know that Batman is inside the Food 101 dataset? So I'm not sure. So ImageNet, we also provide semantic search. So ImageNet, which is a widely used dataset, now you can actually interactively explore this dataset. So let's look for animals or tongue out, cats putting their tongue out. So you can do it very easily. You can also look for other. So basically, this will allow you to interactively, automatically create labels to your data set very easily. Now, all of these quality issues in the public dataset are freely available. You can all just go and download them. We also did release Lion 1 billion. So this is the entire dataset is completely curated, all the quality issues inside. Anyone here interested in generative AI algorithms, ImageNet 21K, and others. So this is a joint effort together with my two co-founders, Dr. Danny Bigson and also Professor Carlos Gastrin. And this is our entire magnificent team doing all the work while I'm speaking here. We are recruiting. If anybody is interested, I will use this venue shamelessly. So thank you very much. You can scan the QR code and it will directly take you to the public VL dataset and you can explore your data. Hopefully it will make your life a bit easier. Thank you.
One question. Did you try this on medical datasets?
Yeah, so we started from FastLoop. FastLoop was used on a huge amount of data. It was used from medical, mosquitoes, up to satellite imageries. So we tried to build a fundamental infrastructure to allow it to work on any type of data set. And you are, of course, invited to try it out.